right, everyone. So welcome to the CDF's member webinar series. Today, our guest member is Codefresh. And today we are going to be learning about what happened to observability in GitOps. And our guest speaker is Dan Garfield. So Dan, whenever you're ready to take it off, give it a go.
I'm ready. Let's do it.
Let's do it then.
So thanks everybody for joining. Excited to chat with you and go through and talk about observability and GitOps. I see we got a couple of stalwarts here. Tracy's on the line. Hey Tracy, good to see you. We're gonna be talking about observability and GitOps. GitOps is of course is a common topic, and we're gonna go a little bit through the history. But I guess before we do that, I should introduce myself. My name is Dan Garfield. I'm the Chief Technology Evangelist for a company called Codefresh, the DevOps automation platform. You can follow me on Twitter at TodayWasAwesome. And I am a member of the Forbes Technology Council, as well as a Google developer expert focused on cloud and Kubernetes and all things cloud native. So I'm a big fan of that platform and have a lot of fun with it. The topic today is, again, GitOps and observability. And so before we go there, I want to kind of contextualize this a little bit. And I think it'll make sense this way. So I want to talk first about what I call the before times. This is in the days of yesteryear when deploying software was a simpler exercise, perhaps, or rather more complicated. It was characterized by monolithic handoffs. You had a monolithic application, typically architecture. Deployments were very manual and they were very periodic, right? So you had these releases that were every couple of months. You'd have kind of all hands on deck. You'd release software. I don't know if any of you, I don't know how old the audience is, if you remember deploying software this way. I remember zipping up my code and sending it over to my operations person to implement. And we would do that every couple of weeks. So this process is very personal. It required a lot of hands-on attention. The risks were very high because you were typically delivering a lot of changes all at once. The changes were very manual. And of course, you could afford that because the architecture was monolithic. You didn't have tons of services you had to update. You had to update a few services, so that made it simpler to do in the sense that you could afford to do it manually. Now, whether or not you could actually afford to do it manually is another question because, of course, any manual process typically leads to downtime. It's not very repeatable. So this wasn't a great situation to be in. So over the last few years, obviously, there's been a transition. We've moved from monolithic architectures to microservice architectures. This allows us to scale our development processes, scale our services independent of one another. Been a really fantastic change. And that means that to support that, we need to get rid of those manual deployments and do more automated deployments, more gradual deployments, things like canary releases, things like using feature flags. And instead of managing, lots of bare metal servers, we can take advantage of Kubernetes, and we can essentially declare what we want as code and rock and roll with it, and we're good to go. Just a reminder, feel free to throw Q&A in there. I'll be watching the chat and I'll try to address it live. I like having the interaction, so let's do it. So I don't know if you've ever had this experience where you are trying to figure out where regression came from. Something just broken, who just deployed, and you maybe just get on Slack and start yelling. Now, in the monolithic world, that's fine. Because how many people could be deploying at a time? You did it once every 2 weeks. You already know who. And even as you started to get just a couple of microservices, maybe this was okay. But what you'll notice is that because we are using microservices, we have way more applications, and identifying the failure points isn't always easy. You might have one application that starts throwing a lot of errors, but it's actually because of a regression in another microservice. So it's not always obvious even which thing is actually broken. That requires an investigation, right? And so if you've got a bunch of microservices and people are deploying regularly, you might start off and say, well, something's broken. Who just deployed? And you'll get a bunch of answers. Oh gosh, quite a few people just deployed recently. And you start to investigate the issue, and more people, turns out, just deployed. And now you're getting more answers. And now you're getting more answers because it turns out lots of people are deploying. You've got 5,000 microservices shouting on Slack that something is broken, isn't scaling very well. We've now become completely overwhelmed just trying to manage the responses to the problems. And they're piling up because there's a service outage and everyone's freaking out and the messages are flying fast and furious all over the place. I once had this experience. We have at Codefresh, we have a lot of our engineers are out of Israel. I don't know if you'll think this is a funny story or not, but we have a lot of engineers out of Israel. And a few years ago, we had an outage, and they started a Zoom war room, and everybody logged in. And I said, I was sitting next to my CEO, who's Israeli, and I said, "Gosh, it must be really bad because they're only speaking Hebrew. They won't speak any English." And he said, "Dan, it's much worse than you know. They're speaking Russian." And so that's not a scalable process, right? So I don't know if you think that was funny or not, but that always makes me laugh. So this isn't really fine. This isn't a great way to decode what's going on. So when it was monolithic, we've kind of taken these habits that we've had when we were managing simpler services. We've, as a I guess, an industry, we've brought a lot of those habits with us, and they don't necessarily work anymore. They're overwhelming. They don't scale. They don't work in a microservice world where you've got, hundreds, thousands of microservices. This doesn't work, right? So this is talking about how we do the scale right. So let's go to GitOps for a second. Because GitOps doesn't necessarily directly address this, but just to reintroduce the topic, we'll start it very simply. GitOps has come under a formal definition. So last week, it was announced the GitOps working group, which consists of AWS, Codefresh, Weaveworks, Azure, and GitHub to start. And we've received a lot of interest and discussion from other companies. And the working group is formed underneath the umbrella of the CNCF. And we've started with the definition, and I've been part of this, so I'm happy to have discussion about the GitOps working group and talk to folks about that. But what we've done is we've put together a formal definition for GitOps. And GitOps has actually been a term that's been used. It's been floated around for the last few years. It was coined by Alex over at Weaveworks, who's really sharp and was kind of leading the way on this. And it's meant different things to different people. Some people feel like it's just infrastructure as a code kind of renamed. It's really just about application management. It's really just about Kubernetes. It's all these things have floated around, and people have talked about different patterns and things. So our goal in the GitOps working group is really to define not only the best practices, but some of the strategies and kind of formal conformance at some point of what it means to be doing GitOps and how what we can actually measure in an objective way. So it's not just people's opinions. It's something that the community comes together and agrees upon as where we want to go. So there are 5 features. First, you have to use a declarative configuration. You need to use some kind of version controlled immutable storage. Usually that's Git, but technically in order to do GitOps, you don't necessarily need Git. It could be, Perforce or or whatever, some of those other older version control systems. You need automated delivery of code. You need to be able to deploy it in an automated way. You need software agents that are actually executing those deployments, that are pulling the changes, not pushing them. And it needs to be a closed loop. So it needs to be able to kind of self-sustain. You can read more detail on those configurations at the links below. I'll throw these in the chat. Oh, wait. No, I won't throw these in the chat because it'll all have to drop out of my deck. I'll throw them in the chat later. You can also just Google them. So if you think about it in its simplest term, GitOps is basically saying, I want to be able to define my application in source code, in version control, and my runtime should come to reflect that. And that's the simplest. Oh, yeah. Taryn got it posted to the plant panelists. I'll copy and paste the link here. So, oh, yeah, she got it. Thank you, Taryn. So that's the simplest way of thinking about it. But we need to actually have a little bit more around it to be within that. First of all, we need an operator. We need something that's actually sitting in the runtime environment that can actually pull changes onto it. So it's looking at the version control, it's pulling the changes, it's applying them, and it's reconciling. So you can think of it like a system of reconciliation to get where you want to go. Now, you actually need something usually a little bit more than that. Now, this isn't necessarily a conformance question, but this is a pattern that is the most common. It's the one that I recommend. You actually have an application code repo where you've defined your application, you're making changes to that. And as changes are made to that, there's an automated test process that fires off in your automation platform of choice. And once that occurs, you can actually have an automated way of generating manifests that then are deployed into a runtime repo. So you actually have two Git repos, one for your application, one for your runtime definition, your manifests and things like that. And this is then what the operator actually goes off of to actually deploy into the cluster. Now, Tracy's bringing up a question. I think this is a good one, and we'll stop here for just a second to go through that. Tracy asks, why does GitOps need an agent-based delivery? Isn't agentless a better way to go? Could it not be an agentless delivery method? That's actually a great question. And if we go to the conformance, which does say that there need to be software agents, the longer definition around that, and I'll pull it up here really quick, just so that I think want to make it super clear. Let me pull this guy up. So here in the conformance blog post, announcement blog post, when we talk about software agents, basically we're talking about reconcilers that maintain system state and apply resources described in the declarative configuration. Now, technically, this agent doesn't have to be on the cluster. Now, that's the most common pattern, but it's not necessarily required. You just need some kind of reconciler that's doing the deployment. Typically, it is on the cluster because it's actually pulling changes onto it rather than having changes pushed to it, which of course would require you to expose your API. But you can imagine a scenario where maybe I have dozens of clusters that I'm managing within a virtual private cloud, and I have an agent, a reconciler running on one of those clusters, but it's deploying to all of those clusters. So I don't have to have any of my APIs exposed outside of the virtual private cloud, but within the virtual private cloud, I could have reconciliation happening. So that's a great question. And it doesn't necessarily have to live on the cluster, but basically it's really the description that there is a role, which is your reconciler. Oh, why does this just have Weaveworks on it? Should have all of them. Anyway. Okay, so we've got our process, right, for GitOps essentially baked here. And this is the common pattern that we see today. This is the one that is the most common, most used. Automated manifest generation is a little bit less common. It's kind of a little bit more advanced. This is what we do internally at Codefresh. This is how we do it, is we generate all of our manifests and then check them into a separate repo. And basically no one's making manual changes. And why don't you want people making manual changes? Because they typically cause problems. We just had an AWS outage last week, and I haven't read the takedown of exactly the cause of that, but I'm thinking about an AWS outage that happened about 1.5 years ago. And it was because a person accidentally scaled, they kind of fat finger to change and accidentally scaled the number of instances of something in a dramatic fashion, and it caused a cascading failure across the entire cloud. So you don't want those things manually happen. You want them all to go through version control. Of course, what I just described means that you were not using GitOps, because if you were using GitOps, that change would have been checked in, would have been tested in some automated fashion, and would have been caught before it went and wreaked havoc and caused downtime for many hours. But the time that you go through the outage, this is really a function of what you know about what's going on. And this is when we're going to get to the observability portion. So here we've got our basic process. And again, I'm using microservices, right? So this is actually just for one application, but I've got 5,000 microservices. So what I actually have looks a little bit more like this, except we'd have to zoom out 4 or 5 more times. So now you can see where the problem starts to come in immediately. If something goes wrong, how do I identify where the problem lies? I have a multitude of services. They rely upon each other in complex ways. Failures in one service don't necessarily dictate where the problem is, because it could be coming from another service that that service relies upon. Now, ideally, you've written your application in such a way that once you look at a failure, it points directly to where the problem is and you can follow the chain. But you're talking about time. The main issue that prevents people from fully embracing automated delivery is confidence that the deployment process is going to work reliably, and that if something goes wrong, they will know how to fix it. So ask yourselves, does your company have a rule like no deploy Fridays? Why? Why can't you deploy on Friday afternoon? Because everyone is worried that they might lose their weekend, that something could go wrong, they'll get paged, and you'll have issues. And so I think, that may be the reality of your organization today. But I think that if we aren't confident enough in our deployment process, that we don't believe that we can deploy on a Friday afternoon at 4:45 p.m. and have full confidence that the process is going to work, then we have work to do. That's the goal. I want to be able to deploy at any time for any reason and have confidence in the process. And that actually is more than just automation. It's observability. It's knowing that this process is not a black box and that you can get lost in. So I might be looking at this complex microservice stack, and suddenly I see a Slack message come up that says something is broken. Who just deployed? Now we saw where that leads, right? All of a sudden, an explosion of people. Oh, I deployed. And you're trying to track down what's going on. So how do you actually identify regressions and where they came from, right? So you've identified that a regression is happening, that there's some kind of degradation. You've gotten alerts, you've got monitoring set up or whatever. So how do you actually identify how to fix it? There's a couple things we need to know to help us narrow it down. First of all, we want to be able to identify when the regression started, because this is going to give us a baseline of where we're going to look for potential changes that have caused this regression. When did changes to our application, to our system take place? What exactly was changed? What issues were being addressed? Who worked on it? All of those things will help you narrow down very rapidly what's going on. Now, your system, excuse me, will probably allow you to do rollbacks, and we definitely recommend that. Usually Git-driven rollbacks are ideal. But you may have a regression that started, at some point in the last couple of hours, and there may have been dozens of deploys during that time. So you don't necessarily know which one you need to revert back to. And furthermore, you have, hundreds or thousands of microservices. So do you even know which service needs to be rolled back? And if you do a rollback, what will happen if someone pushes additional changes? Will those have the problems that cause the regression again? So you can see how, as you scale this thing up, yeah, I can understand why some people might not want to deploy on a Friday afternoon because answering those questions feels difficult. So let's leave the theory behind for a minute, and let's go back and actually look at a practical example. And what I'm going to do is I'm going to pull up an application that I'm managing. Now, this one's fairly simple. This doesn't have the two-step kind of system that I've described, but this is a repo that I use to manage my Atomic cluster, which is a Kubernetes cluster that I have sitting on my desk that I built out of Atomic Pies. It's x86. It's really fun. I actually just did a KubeCon talk on that, which you're welcome to check out. But you can find this on Today Was Awesome, github.com/todaywasawesome/atomic cluster. I'll throw that in the chat too. So what I have here is I have a number of apps that are defined, and I can look and you can see that I have this YAML here that defines what is going to be running for netboot XYZ, which I have running on my cluster. And if I'm actually using Argo. So if I pull open Argo, we can see that netboot XYZ is currently healthy and it is currently synced. So I can actually see that, yes, it's currently running the latest version. And I can see that that's proceeding as, everything's working fine as I would expect. And if I were to make a change, so let's see, right now it's running, version 2027 is the latest version that's running. So let's say that I were to change this to version 063. So I'm going to save that. And let's go ahead and commit that. Zero 63. Oh, it's good to commit in front of people. Reminds you to do things correctly. All right, Git has been committed, so I'm going to git and push origin, and this will fire off my change, right? And if we look now at Argo, Argo will pick up this change automatically within, I think it's set to check every 60 seconds or something. I'm just going to tell it to refresh, just so we don't have to wait. So you can see it's now out of sync and it's now syncing, and this is progressing. So we can actually see it's spinning up the new pods and rocking and rolling those things. And so once this one is started, this one will go away, right? Oh, actually, this one is going away. Yeah. So, okay. So now we've completed an update, right, to the cluster. So it went pretty fast. So you can see how the mechanisms of this work. And if I were using this, I can actually use this inside of Codefresh as well, because I normally, would have a CI process. We're not going to get into the CI process elements here, but if I go over to my GitOps dashboard in Codefresh, you can see that the netboot XYZ is synced. And so it's actually showing me a similar amount of information, but I can see all of the deployments that have happened today. So I can actually see them as they're occurring in real time. Refresh that. Should show up. So this gives me time, right? Which is one useful metric. But let me show you a different example of how we solve this problem. Because remember that I said that there are a number of things that I want to know. I want to know what changes occurred, what were the commits, what were the issues. So I'm going to show you how we actually tackle this internally to get the visibility that we're looking for. So here you can see I'm actually in the Codefresh platform, and it looks like there's currently a release happening on our production. So let's pull up production and see what's going on. Now, let's say that I had identified an issue that occurred at 10 o'clock this morning. I can actually narrow down and see exactly when my deployments have all occurred. And so here's my 10 o'clock range, and I can jump straight to that one, and I could find out what was going on with this. So this was about 2 hours ago. I can see that it was Dennis at Codefresh that worked on this. Didn't have a Jira issue, but it did have a pull request, so I could jump over to that pull request and try to and see what actually changed and see if that actually fit the profile of the issue that I'm having. If I let's look at the one that happened most recently. This one actually has a Jira issue associated with it as well. And if I go to that, I can actually see that there's, it's actually a pull request related to the integration with Argo CD application owner. I'd like to see the title of the PR issue in the filter. Oh, that's cool. So in the last hour, in my filters, I can now add specific pull requests and look at how those were occurred. So you can see how this is actually going to help me solve those problems really quickly, because as I have the time frame of when an issue occurred, I can actually identify all of the rollback, all of the releases that have happened in that period, and drill down exactly to what's going on. And you can see this is actually managing dozens of services within this. And so these are all, this last update updated all of these services within my production cluster. And I can see, of course, which pipelines executed, and I could jump into those pipelines and actually see what changes have occurred. So the purpose of this is really to solve the issue of observability. I want to know if something's gone wrong. I need to have confidence that I can very quickly identify where the root cause of that is. And if I know when my regression started, I can then drill straight down into the change set and identify exactly what's gone on there. And this is something we just launched externally 2-3 weeks ago. But yeah, you can see not only that, but I can also go like if I expand this view here, if I go over to my PR, of course, then I actually can get the code diff and actually see what code has changed. So this makes it, I'm not going into Slack anymore. And that's a real use case. I'm not going into Slack and shouting, hey, what's changed? Who's been doing stuff? I can actually just go straight to my dashboard and see not only the status of production, I can see it's all healthy, everything's running properly, but I can also see and narrow down the entire history. So it's not just about what is currently running, because as you can see, we're making changes quite often. We had a change an hour ago, we had one 2 hours ago, 3 hours ago, 5 hours ago, 6 hours ago. I could issue a rollback right from here and get to a working version if something had gone wrong, and address that very easily, right? And so you can see how this works. I can see all the different committers. I can see what they're doing. This gives you a lot of confidence in your process because you can see what's actually going on and drill down into that. So I'm going to come over to the questions here in a second. Something else I did want to mention actually before I get into those is the other thing that we do that really helps is we use shared pipelines. So what we do is we create a single pipeline, and I can show you this here. If I go to the CD pipeline here, what you'll see is we've actually defined a pipeline that triggers the update of all of the elements that are going to go into a sync. And this is a shared pipeline. Now, what does that mean? Well, the old way of doing this is you have one application, one repo, one pipeline. And that works great when you have a couple of applications or a dozen applications. When you have 5,000, now all of a sudden you have to maintain 5,000 pipelines. And if you want to add a security step, this is something we actually did in the last last week and a half is we actually added some additional security policy scanning to our pipelines. That means I have to go and update 5,000 pipelines. So what we do is we have a shared pipeline, and the shared pipeline operates off of different triggers. So you can see that this is, because this is a CD pipeline, this is actually operating off of a single repo, the CF Helm repo, that stores different Helm charts that are meant to be deployed into production. And so the CD pipeline, as a pull request is opened, this will actually go and test and validate that the change that is being pushed is going to work properly. And then it actually, even as a step, triggers the Argo sync as part of the pipeline, and then can do a rollback if it needs to, or those kinds of things. So in this case, it's actually not even it's not using the automated sync feature of our deployment agent, but it is being triggered instead by this automation, which allows us to build some additional logic and barriers and things around it. And this is on the CD side. And if we go back over to the CI, this is another shared pipeline. So you can see this one also has dozens of microservices associated with it, all from different repositories this time. And this one, basically at the end of it, opens up pull requests onto the CD pipeline, which then it opens up pull requests onto the repo that has all of our manifests in it. So you can see it adds a pull request on and sends the Helm package onto that repo in a pull request, which then is tackled using my CD pipeline, and then of course deployed in an automated fashion to my production cluster. So definitely recommend that. And the other nice thing about that is that in your GitOps element, of course, that means I can actually represent all of these services with very little, configuration overhead, because it's not just about the pipelines. It's about the changes, right? It's about the code changes as they happen. So let's go into the questions. This is what I wanted to share with you today, is a pathway towards observability. And doing that is really about gathering all of the information into one easily searchable place. And this is what we've been working on internally. You're welcome to check it out at codefresh.io. But let's go into these questions here about GitOps, and we can have any questions about GitOps in general. Johannes asks, possibly a question for the end of the talk, are people using GitOps mechanisms outside of the Kubernetes world? That's a great question. Yes, I am seeing this in some places. You'll see people doing it purely with infrastructure, right? So they'll be doing, Terraform or those kinds of things to try to accomplish GitOps. I like to think of GitOps as sort of an adoption curve. What I outlined earlier is like, this is the official definition of these are the ingredients to be doing GitOps, and you move towards that, right? So people are starting to do it on other platforms. There's nothing about it that makes Kubernetes a requirement. But Kubernetes is certainly one of the easiest platforms in which you can describe your application runtime as code. So it makes the GitOps process easier to accomplish, but you can definitely accomplish it outside of Kubernetes. And we're actually at Codefresh, we're working on building some really cool GitOps tooling around serverless. So I'd, stay tuned for that. Something that we want to get out there very shortly. And of course, if you're interested in participating in the GitOps working group, go ahead at join us on GitHub. Just search GitHub GitOps working group and you'll find us. Tracy asks, could Ortelius push a microservice into a shared Codefresh pipeline? For example, the team is working on the concept of truth tables, pushing a microservice through a pipeline based on a risk level, which may change over time, become less risky, or require more scrutiny via the pipeline. So I guess the question is, how dynamic are those shared pipelines? They're super dynamic. So the shared pipelines actually sort of enforces a standard about how your application is defined. And so a trigger, which is like saying there's been a change to this repo, you can do those through a CLI. So there's an API for it as well. So if you're using Ortelius and you want to say, oh, go trigger this pipeline, you could actually do that. And you can say, this is the context of what I want you to test. This is the repo I want you to clone. You could pass in all, whatever variables you need. And at that point, you can actually run all of the additional testing and things that you want. And you can also pass parameters. So it could be a single pipeline that takes parameters in order to decide what risk level of testing scrutiny you want it to go through. Or it could be a few different pipelines that you trigger based on your logic in Ortelius. So it's up, I think that's cool use case. And I would love to see that talk. I would love to see that with Ortelius. That'd be a lot of fun, Tracy. We should do that. Neil asks, love the single CD pipeline. It means you have a single pane of glass on change. Follow-up question on Johannes. With multiple plus legacy tech, i.e. not just Kubernetes, how would you homogenize a CD pipeline across many different implementations? You said to Tracy that this enforces homogeneity. Okay, so that's a good point. If you're using different, so in our case, we're using a CI pipeline and a CD pipeline. Now the CI pipeline could be potentially non-Kubernetes dependent, and then your CD pipeline could be. And so you could actually have potentially multiple different CD pipelines depending on what's being deployed. You could have it as a step in your pipeline that it's deciding how it's going to define whatever it's going to be deployed. That could be Terraform that's not working on Kubernetes. It could be some other infrastructure as code thing. Those could all be, when I say it forces homogeneity, it enforces a pattern, right? So whatever your shared pipeline operates becomes the pattern that the applications have to follow. So for example, in ours, we clone a repo and we build a Docker file that is, and so that means every repo, every application that we work with, it's enforced that you have to have a Docker file if you want to use this pipeline. Now, if you want to go create another pipeline, you want to have a different process, that's possible. You can totally do that. That's fine. But if you want to deploy, and let's think of like Nomad, maybe we have some people using Nomad. I could very easily foresee a scenario where we have the Nomad configuration in a repo and the Kubernetes configuration for an application in its repo, and it's basically consuming and looking for the configuration in the context that it needs to operate and actually deploy. So you could easily envision, a scenario where you have a single CD pipeline, but you're actually supporting multiple deployment, strategies. Or potentially a combination. So you could have one that's Kubernetes, one that's Nomad, one that's your Android application, whatever. But it still allows you to reuse those pipelines in a kind of a centralized way, because even if you have multiple pipelines, you don't have 5,000, right? So you have 3 that cover your 3 specific different use cases. And that becomes, if we're doing Kubernetes, this is the path. This is how it works. This is the policy. If it's Nomad, this is the path. This is the way that we do it. If we're using serverless, this is the one. And so you could see a scenario where you have, 4 or 5 pipelines that are actually doing the heavy lifting for 5,000 different microservices that are all running on different infrastructure. So yeah, I think that would be cool. This is the way. Well, I don't know if we have any other questions. I think, there is another one. Sorry. Neil asks, does the single CD know about the Nomad and K8's implementations, or do the individual implementations expose a common interface? Oh, okay. Actually, this is a cool topic. So this is a little bit off topic, but I can tell you how we do it in Codefresh. So in Codefresh, the resources that I want to deploy to are defined as objects. So I actually define my cluster, my atomic cluster, for example, is a defined cluster that exists. And so I can now reference this within my pipeline. So if I went to, let's say I was going to add, I can actually reference a cluster as an object in my pipeline. So if I were, we'll just pull any random pipeline here really quick. Let's say that I wanted to deploy to this not using my GitOps step, but just for an example. Oh, whoopsie. Let's go to my settings. Workflow. In my steps, maybe it's this huge steps library. Let's say I was doing a Kubernetes deployment. What I would do is I would just pass in the reference to my cluster. Now that cluster actually has permissions around it and security and stuff. So I can actually say like only certain pipelines or certain people can actually update it. So there's, permissions and security and stuff around it. But yeah, I can actually use it as an object. Now, not only that, but I can define variables at my pipeline level, at a project level, and at an account level. So even if I was using something like, Nomad is supported, but not necessarily as an object, I could actually add my Nomad configuration to a global configuration, and then I can just reference it. So if I go to use the Nomad step, I think there's one in here. These are all open source, by the way. Oh, maybe there isn't a Nomad one. We do have an example in there somewhere. I got to go find it. Anyway, yeah, I can just reference that as an object that then has the proper permissions and stuff around it. So that could be a lot of fun. Let me see if or do the individual implementations expose common interfaces? I think what you're asking, Neil, is actually a little bit deeper than what I've answered, which is like I have my GitOps dashboard that shows me the status of all of my applications. And this right now is within Codefresh only a Kubernetes feature, but I don't think that's the intention that it would stay that way. So we did design and architect it in such a way that we could potentially add additional here. So we're going to be adding serverless into here, and we're going to start exposing serverless that way. Simon says, great lecture. Thank you. Is it possible to get your presentation? And the answer is yes. You know what? We'll go over to the final slide here, and I will throw a link in the chat. I have some extra slides I need to clean up at the end, so nobody get too riled about that. And I'll remove those post haste, but I'll throw these into the chat right now so you can get a copy of it. And I think we'll send out an email probably in the follow-up. So thank you everybody for joining. I had a lot of fun. This is a little bit different kind of presentation. It's a little bit more low key. I felt like it was a chance where we had a little bit more conversation, which I really enjoy. Again, you can follow me on Twitter at Today Was Awesome. Love to have follow-up conversations with any of you that would like to. Please reach out and happy to chat. So with that, I will say take care and good luck. And I don't know if there's any other commentary from Jacqueline that you want to do.
Yeah, I just dropped in. Yes, thank you so much, Dan and Taryn, for joining us, and Codefresh for helping out. This is awesome. I'm really glad that you guys are taking advantage of our channels. I dropped in the link for the YouTube playlist for all of the CDF member and ambassador webinars. So as soon as we get off this call, I'm going to do a little bit of editing, and then I will make sure that this video is uploaded to this playlist. So if you want to watch it there again, yeah, please feel free to take a look. But thank you so much. I had a lot of fun learning about more about Codefresh and GitOps, and appreciate your time as always.
Thank you. Take care, everybody.
Thanks, everyone. Happy holidays.